No countdown. Hello and good day, geometry. We are continuing with proofs. We filled all this stuff out yesterday. If you missed it, check out the video from yesterday. And we are going to go on to the next two proofs on our sheet. PO24 part 2. Basically, we are writing proofs. We're proving that triangles are congruent. Just to kind of give us a reminder, the 5 ways that we can prove triangles are congruent: side, 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 angle, side, angle, side, angle, 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 side, and HL. Okay, you're looking to get one of those 5 combos for the corresponding sides. If you can prove all 3 sides are congruent of both triangles, the triangles are congruent. If you can conclude 2 sides and the included angle, and so on and so forth. Okay, so right now, looking at this picture, what do you see?
Right angle.
A right angle. Which one of these 5 has to do with right triangles? HL does, right? So immediately we kind of have a plan here. We're looking, it seems to be set up well for HL, okay? Which means we need to prove that the hypotenuse and the legs are congruent, right? We'll see where it takes us. Like I said, it's kind of open-ended here. So for starters, as every single proof starts, we begin with our given statement. Okay? D is the midpoint of AC.
Wait, where'd you get HL?
You were gone yesterday. You're going to have to watch the video for it. It's one of the 5 ways we can prove that triangles are congruent. HL stands for hypotenuse leg. Okay? Because math is a G-rated subject. But you'll have to watch the videos so that you can.
Otherwise,
Otherwise, be angle side side.
Huh? ASS.
Oh well, there it is.
Oh,
Yeah, I was
that's a naughty word!
trying to avoid. I can't make this video for kids now. I gotta market it. Ah, gosh.
Naughty word for you.
Oh, there it is.
Oh, they heard it.
Already getting.
The phone's ringing.
Yeah, thanks. So anyway, so D is the midpoint of segment AC. No, I'm not underlining the word the. That is the symbol for segment AC. There's also something else that is given to us, not in the given statement, but marked in the diagram. Priya, what is that?
There's a right angle.
Yes. Also, angle BDC is a right angle.
Do you have to write that?
And that is given. Yes. That's all step 1. That's all the information that we are told.
Wait, there can be words in the first column? What?
Yes.
I thought it was just.
There can be words in the first column. Okay? It says D is the midpoint of segment AC, and then angle BDC is a right angle. Okay? I'm actually going to redraw this because I didn't give myself enough space for my statements. I'm going to end up having to abbreviate and squeeze them in there. And just so you can read them better, because I'm all about your ease. That's what I care more than anything about. Number 1.
Oh, isn't there another good?
D is the midpoint of segment AC, and angle BDC is a right angle that is given to us. Okay? Now, whenever, James,
Isn't there another given?
what's that?
Segment AD and DC is equal?
Okay, now that's not given to us, right? But why can you say that they are? How do we know that AD is congruent to CD? And maybe I have to have the correct order. AD and CD, yeah. James.
Because of the midpoint?
Right. Here's a proof hint, okay? Whenever you are given a vocab term in the given statement, your step 2 should be define what that means. Okay? You are given a definition, a vocab term. Midpoint. What does midpoint mean? It means it's the middle point of a segment, right? Which, as James then said, that means we can conclude that AD is congruent to CD, right? Step 2. AD is congruent to CD because
Definition.
the definition of midpoint. Okay, yeah.
Well,
Okay. I can write out midpoint. Come on, Schultz, don't be so lazy even though it's a Friday. Be there for these kids.
can I put def of
No!
midpoint?
Do what I'm doing.
Definitely.
Otherwise you're conceding I'm more fit.
FP.
Okay? The other thing in our given statement is this BDC is a right angle. Okay? What does that tell us? Abe?
Phone ringing. Phone ringing.
They must have had to read. Back at it. Take 3. Here we go. What were we talking about? Oh, Abe. BDA is also a right angle, right? And what do we know about right angles?
They equal 90 degrees.
They equal 90 degrees. They're congruent because we literally have a theorem that says what?
Right angle.
All right angles are congruent, okay? So step 3, we're going to say that angle BDA is congruent to angle BDC. And the reason for that is the right angle congruence theorem. Okay? Right angle congruence theorem. Yes?
Wait, couldn't you also use like vertical angle and linear pair too?
We don't need to because it's a right angle. But yes, that is, yes, if it was any other measure, then we could go that route there. Okay? Now, like we did yesterday, we kind of paused and we said, let's take inventory of what we have here. Okay? We have AD is congruent to CD, that's a side. We have angle BDA is congruent to angle BDE, that's an angle. Now, I originally said HL is a great candidate for what we're doing here because HL, you know, we have that right angle. We need the hypotenuse and the leg. We've got the angle. We have the legs congruent. Is there a way to prove that BC is congruent to BA? Girls, you're going to want to focus on this and pay attention. I don't know how else to say it. Like, Emmeline, you're taking notes, right? Jotting this stuff down, okay? You're going to watch the video tonight, get caught up with everything, okay? Is there a way to prove that AB is congruent to CB for HL? Or what other one of those 5 would be a potential candidate here for a way to prove these triangles are congruent?
Is side angle side one?
Side angle side too, right? Because we have an angle, we have a side. Either we need to prove that the hypotenuses are congruent, which I'm not saying they are, that's why I'm doing it in blue, okay? These are our options here. That would give us HL. Or we prove that BD is congruent to itself, and that would give us side, angle, side. We can eliminate side, 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 angle, side, angle, 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 side. We only have one of those, okay? Which one of those 2 options are we able to do? Mario.
BD is equal to DB.
Why is BD congruent to BD?
Reflexive.
Reflexive. Segment BD. Remember when I told you to star the reflexive and you'd fall in love with the reflexive? Okay? I also said yesterday, a proof hack, anything that is shared, anything that overlaps, it's a gimme because of the reflexive property. Something is congruent to itself always. Okay? And this is because of the reflexive property. Right? So now we have our third piece. We have 2 sides and the included angle. So we can definitively say now that triangle ABD, step 5, triangle ABD is congruent to triangle CBD because of side, angle, side. Okay? Woo! Questions on that?
Can we do
You want to try it?
No.
Sure.
Yeah.
I'll pause it. Give it a try. There I am. Okay, so technical difficulties. Someone came in and erased all my ink.
Oh, sure.
Definitely.
Okay, so we're going to start over again. We were almost done. Statements and reasons. Number one, always start with what's given. Angle NKM is congruent to angle LMK. And also, angle L is congruent to angle N. And that is given to us, given information. And so, let's just stop and take stock here. What do we have? Gus,
Angle, you have two angles.
we have an angle, and we have another angle.
Wow.
Right? And they're marked for us in the diagram also. Okay? So our 5 ways that we were talking about earlier, side, 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 angle, 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 side, angle, and HL, which ones are we kind of looking at here?
Angle, side.
Or angle, side, angle, right? We already have 2 angles. I mean, side is definitely out. Side only has 1 angle. We already have 2 of them. HL, I mean, no right angles marked here, so that one's probably not. We're looking at these 2 here. And so we've got to find a side and determine, is that side in between our angles for angle, side, angle, or is it outside the angles for angle, angle, side? So can anybody see a side of both triangles, corresponding sides, that we can say are congruent?
K and M.
KM? Why?
Well, it's on both.
It overlaps. It's your gimme, right? KM and MK, this segment right here, it's part of both triangles. That's your gimme one. Reflexive property for the win yet again. Okay? Step 2, we can say that segment KM is congruent to segment MK because of the reflexive property.
But why do we need to say that?
Isn't this symmetric?
This is.
No.
I don't know how many times.
No, symmetric is when you have 2 different values, you're just reversing the order. Symmetric would be like A equals B, therefore B equals A. A and B are different, but you're reversing. These 2 things are the same. The reason why they're written the way they are is, again, back to that congruency statement. We have KM being the second and third letter of one of them, and then we have MK being the second and third letter of the other one. So in order to keep that consistent, that's why it's written KM and MK right that versus KM and KM. Okay? But now we have a side. And so we need to look and say, okay, is this side in between our angles or is it separate? And if I just separate this triangle and draw it over here, right? Here's our triangle, it's kind of looks like that. We know that angle N, like here's point N, here's point K, here's point M. We have angle N marked congruent. We have this angle in the bottom corner marked congruent. The side that we mark congruent is right here. Right? Is that angle, angle, side, or angle, side, angle?
Angle, side.
Angle, angle, side, right? That side is not the one that is connected by both angles. It's not in between them. So our third and final step here is that triangle NMK is congruent to triangle LKM because of angle, angle, side.
Well, doesn't it already say that? From the start?
No, that's what we're trying to prove. We had to write a proof to say that this is what we know, this is where we want to get, here's the evidence that gets us there. Logical evidence, step by step.
You go into the
Evan.
So when we say angle, angle, side, or angle, side, angle, is it just the order we do it in? And then, are we gonna do proofs for like a whole year? Or is there like proofs?
Proofs come back in PO26, and that's pretty much the last time. I mean, this comes up on like, you know, test reviews and stuff like that, but. Before our next test.
Why can't we just write mine is on the teacher?
Okay, questions on this?
What's our whole?
Okay.
I thought we have our whole next page is homework.
Oh, I can't complete any of those.
Let's do.
The first one was easy. Can we please do that one?
Can we do the whole page is homework?
I'm on part 4 right now. Please go to PO24 part 4. I would like you to do this one right here.
What one is that one? That's in the middle.
I can't.
PO24 part 4, the one, the QRS and TUS there.
Oh.
Boy doesn't know what alphabet.
Wait, what?
Okay. Now, this one you'll notice doesn't have a given statement. When that happens, what's given to you is what is marked in the diagram. So I'll kind of get you started. Here's your SR, statement reasons. Okay? Our first statement is going to be exactly what we know, which is that QS what order am I using for the other one? What's the corresponding part to QS? TS. And we know that because QS is the first and third, TS is the first and third. And also we know that RS is congruent to what would the other one be?
US.
US, because second and third for RS, second and third for US. In this case you wouldn't write given, you would write marked. And that it was marked in the diagram for you. Means the same thing, but because there was no given statement, you write what is marked. Okay? Take it from here. I'm going to pause it. Again, such a choppy video. Zoom and we're back again. Okay, so here's what we have, right? We have what's marked in the diagram here. We took stock. What do we have? We have a side and a side. Okay? So either, marked in blue here, we said we had to find that third side. Is there any way to prove that QR is congruent to TU? Okay? Or we could go with side angle side. Is there any way to prove that angle QSR is angle TSU? And like I said, this is where recognizing relationships is so important. Recognizing that, hey, I've got two angles that are across from each other or opposite of each other at a vertex. That's the definition of vertical angles. Okay? And so I had some people ask, is this what you would write? Angle S is congruent to angle S. Why is that a problem here? Why can't we use just one letter? It could be the same angle, or
Because there's 4 angles.
there's 4 angle S's, right? This, and this are all technically angle S because it's the vertex of all of them. So we have to be a little more specific, and we have to say that angle QSR from Q to S to R, that specifically describes this angle right here. And then QSR, following that same order with our second triangle, would be T to S to U. Okay? And we got that because of vertical angles. Now we have our third part, which is an angle. And luckily, there's only one of our 5 theorems that has 2 sides and 1 angle. So it has to be side angle side. Okay, there's no other options. So step 3, we can say that angle or triangle QRS is congruent to triangle TUS
Didn't we just say that?
because of side angle side.
What's the difference between?
No, because we do have all.
AAS and ASA, the congruent side you have is in between 2 congruent angles versus it not being in between.
Wait, so basically, like, it might be angle here, angle here, and then
Side in between.
for
Yep.
SA, and then it has to be angle, angle side.
Correct. Andre,
What's the difference between the second and the third angle?
the second step names a specific angle as being congruent. That's why I use the angle symbol here. The third step says the whole triangle is congruent to the whole other triangle.
Wow.
This combines all three of these corresponding parts that we have here. This is just a singular angle. These would be the whole triangles.
Can I explain it in a way you understand?
Sure, Evelyn, take.
So,
Take
you see
over.
how the S is in the middle and that's where the vertical angles are? He had to write it in a way where it was an angle and the S was in the middle on both sides, so that they would be equal.
Because we're naming a specific angle.
And that also makes it a vertical angle.
We only had two parts of the two triangles congruent, the two sides there, right? So we had to find the third part. We had a side and a side, so we had this, we had this, we had to get the angle, right? So step 2 is naming that angle, these two angles right here, which now I can put in red because we know it. We had to name these two angles congruent so that we could use side angle side.
I just don't get like what order you put in.
The order comes down to the congruence statement. As Evelyn said, S has to be in the middle because that's the vertex of the angle. And so what we said was the angle formed by starting at point Q, going to point S, and ending at point R. Going from point Q to point S, ending at point R. That angle right there is congruent to the angle going from point T to point S to point U. T, S, U. Folks, what's going on back there?
People singing in the hall.
Yeah, they're doing their skits for the,
That is not a part of the skit.
what are they singing?
Think of it.
What?
Think of it.
By KSI.
Some streamer. It's a cheating song.
Emily? No.
It's a
Yeah.
Because like you know how there's A, S, and then like A, S, A?
Yes.
How do you tell, like, how do you know what order is it like left to right? Is it like...
It's just as you move around the triangle in either direction, if the side is part of both angles, then she's asking a totally different question right now. If the side is part of both angles, then it's ASA. So like the difference that we drew on our front of PO24, angle side angle would be if you had these two angles and the side that connects them. That is angle side angle. Angle side angle, ASA. An example of angle angle side would be if you had two angles and then like a side out here. Angle angle side. Okay? It's on the first page of PO24. We wrote if you drew the pictures. Yeah. Okay? Okay. The one on the left. Let's get us started before we leave here. It says prove triangle UWZ is congruent to VWX. So UWZ is the triangle going from point U down to W and up to Z. So this triangle right here. And we want to prove that's congruent. The triangle VWX, which is from here down to here and up there. So VWX right there. Start with our statements. Excuse me. Thank you. And our reasons? Again, no given statement, so we go to what is marked. Angle Z is congruent to angle X. Why do I only have to use one letter here?
Because it's just
Evan.
there's like no intersects.
There's only one angle at point Z, right? Z is the vertex to only one angle here. I couldn't just say, angle V, because angle V has two angles it could be, right? But angle Z only has one option there, okay? Then, we also know that side VW is congruent, and then again, order matters here, VW, first and second, to UW. And all of that is marked.
Is that like
Okay?
how many points are gonna be on this test?
This objective is worth 4.
Isn't there one where it's like
But it is a PO, so.
I don't think I'm passing the
Okay.
Good though.
So, let's stop and take stock. Folks, we have an angle, we have a side. Okay? So there's really, there's still a lot of options here. We could have side, angle, side, angle, side, angle. We haven't really narrowed down a ton. So first thing to ask yourself, is there a vocab word? Because remember, if there's a vocab word in the given statement, defining it will give us a part. Like the midpoint one that we did earlier. Is there a vocab word there?
No.
No. Second thing you want to look for, Audrey, it's going to help if you are looking this direction when we're talking about things. Okay? Second thing to look for, does anything overlap?
Yes.
Yes.
That's your gimme. What overlaps?
Oh my gosh, isn't that a vertical
There's no
angle?
T.
What overlaps?
W.
Angle W.
Oh, angle W.
Angle W is a part of both triangles, right? This triangle here, we want to prove that is congruent to this triangle here. Angle W is part of each of them. So we know that angle W is congruent to itself because of
Reflexive.
reflexive. Okay? So, we now have two angles and a side. Our job now is to determine whether or not it's angle, side, or angle, side, angle. And to do this, it's tough to look at it when the triangles are overlapped where they are. So I'm going to take triangle ZWU and just kind of draw it over here. Here's point Z, here's point W at the bottom, here's point U over here. We have Z marked congruent. We have W marked congruent. And then we've got UW marked congruent. It's easier to see now. Is this angle, side, or angle, side, angle? Angle, side. Because this side is not in between our two angles. It's tough to see it. It's tough to see when they're overlapped. Slide one of them over, mark your congruent parts, and it's easier to see. So, step 3.
Side angle.
Triangle UWZ is congruent to triangle VWX because of angle, side. Pen drop. Okay? Alright, no homework for Monday. Have a nice weekend.